Hello everybody, this is Unit 3, Lesson 4, Topic 4, and we're getting to the selection sort. So, let's see what we know at this stage. We know how to sort an array of integers or doubles or strings. There is a method in the array class that we're going to use. And have a look, we can now use some existing knowledge. So somebody else coded a class called array, same as what we code a class called student or employee or person. They coded an array class. They provide quite a few different methods for us in the class that we can call. So these, we saw that these binary search methods, we only know about a linear search that we use a normal loop for. So we're not going to call any of the binary search methods, but I can, using a binary search, I can search an array if I want to call those methods. If I scroll down a little bit, we're going to get to the sorting methods. A little bit down still, over here. So I can now sort, and that's the big catch. I can sort a one-dimensional array. So array only of integers, or only of strings, or only of doubles or decimals. I can easily sort with a method that somebody else coded that they provided in the arrays class. So somebody coded this method for us to do all the loops and the things that we're going to see how to code. We simply send our array as a parameter, but the limitation, it's got to be a one-dimensional array. An array only of integers, or only of strings, or only of something like that. We obviously want to go and sort now an array of objects. So all the employee objects are saved in an array and I want to sort them. Either per surname, per employee number, per salary, whatever I want to do, I need to sort them. So there are actually quite a few different sorting algorithms available. If I go to tutorials point, there's a bubble sort, insertion sort, selection sort, merge sort, shell sort, and quick sort. Now these sorting algorithms actually comes from mathematics. Our data structures comes from that as well. Long ago, before computers were even a thing, mathematicians devised ways and means of storing data on paper and then searching and sorting through the data. So these algorithms actually have got a basis in mathematics. We're only going to pay attention to the selection sort. That's the only sorting algorithm that we introduce to beginners. It's the easiest sorting algorithm. It's not always the best to use with big data, but the coding is the easiest. And this is then the first algorithm that you guys need to know, that you need to be able to, even next year when I ask you, come, selection sort, you need to be able to tell me what's the steps, how to do it, what we're going to do, all those things. So we're going to talk about selection sort. And using selection sort, we can now sort an array of objects. Before we get to sorting an array of objects, I want to have a look at swapping array elements first of all. So, if I can have a look at this array, and I want to swap, let's say element 10 and element position 0 and 3, I want to swap the 10 and the 14. What do I need to do in order to swap it? At first glance, those two steps looks perfectly fine. Yeah, they're gonna sort the array. All is good. But if we actually go work with it, then what does this say? Take element at position 13, copy that. So here we go, copy and save it in the first element. So that really goes in, oops, replaces the data for me. I didn't copy. And then I say take the data at element 0 and save it at element 3. So that again says copy and paste it here. But oi, have a look at the result. I've got 14 and 14 now. That's not what I wanted. I wanted to swap the data. So this is not the right way to swap two array elements. Let's just reverse the process. In order to swap array elements, I need a temporary variable. I need to use that as well. And what we're going to do is to first save, let's say, the first value that I'm replacing that value first. So in a temporary variable, I'm going to save that. And now right at the end, I'm going to get my data from that temp. So temp must be of the same data type as my array. In this case, it would be integers. I'm storing integers. So if I now go through the steps, I say take the data at position 0, copy it, paste it, save it in temp. Then take the data at position 3, copy it and paste it. Then take the data in position 10 or in the variable called temp and now go put it in position 3. Okay? And what's the result? I actually swapped my data. Okay? So this is the first thing that you need to know. How do I swap two array elements? And it's rather simple. I need a variable where I'm going to store the data. I copy and I'm now going to assume I need to swap position 0, index 0 and index 3. So first save the data in index 0, copy the data from the other index there, and then from the temporary variable, copy the data back. And that in the end would be the steps to swap my array elements. If I go down a little bit, we need to have a look at the selection sort algorithm in detail. Now, if you go to something like YouTube and you tell, stop, thanks. You tell YouTube you want to have a look at selection sort. Then YouTube tells me, there's one video, there's a next video, here's a next video, there's a next video. And everybody is an expert on explaining selection sort. So, how many different sorting algorithms that we can find? Careful, don't look at too many videos. I don't want you to go and get confused. Okay? They should all have the same formula and steps. If you have a look at the selection sort video, or the explanation rather, at tutorials point, I rather like this. So they tell me, first of all, it's a simple sorting algorithm. Okay? It is really, the coding is simple compared to some of the other algorithms. That's why we use it for beginners. And what they really tell us is we're going to divide the array into an unsorted section and a sorted section. Okay? And right at the start, the whole array would be the unsorted part. And then gradually as we go, we're going to sort the data in the array. Let me have a look at my explanation first. Okay? So we're normally going to either sort the data ascending or descending. So from low to high or high to low, you always need to have a look, see what is asked. We are going to use nested loops, so you must make sure you understand nested loops before coming to the selection sort algorithm. And then when we're going to work, we're going to sort, we're going to pick the first index and make sure that index would have the lowest value. Then we move to the next index and again make sure that this index would have the lowest value, and so forth and so forth and so forth. Okay, one at a time index we're going to do. So we're going to search for the minimum or the lowest value, and then we're going to always swap the data as we need to. I'm just going to remember those steps. Let me manually do it for you right at the start. So right at the start, we're going to start at index 0. I'm busy with this. I want the lowest value in the first position. So now I'm going to search through the remainder of the data to find the lowest value. And I'm going to find it obviously at position 10. And then what I need to do would be to swap these two. And we already know how to swap. So I'm just going to say, okay, we're going to swap 10 and 14. And now all of a sudden, guess what? First value in the array is sorted. I've got only one element that's sorted, but it's sorted. And now we move to the next element. And again, in the remainder of the array, we look for the smallest value. We get it at position 3. It's the 14. And we're going to swap the 33 and the 14. The moment we've done so, our sorted section of the array now includes 2 elements. And then we move to the next element, 35. And again, we search in the remainder of the array. There's only 2 elements left. But we search for the smallest value and we get 27. So now we will swap the 27 and the 35. And that then sorts that section. Then we go to the next element. And we search in the remainder, but we didn't find a smaller value. So that means no swapping needs to be done. Automatically the 33 would be in the smallest, the smallest of the remainder of the data, and I don't need to sort the last element. It will automatically be sorted already. And voila, those are the steps. Now we need to just see how we're actually going to implement that in programming. So again, in the tutorials point video, they try and tell us exactly how they're going to sort the array elements. So they say, assume we've got this whole array to be sorted. We're starting with position, the first position, and we search through the array to find the smallest. And we already know how to search through an array to find the smallest. I gave you an algorithm a while ago. So we're going to use that a little bit. Get the 10, and now the 2 values are swapped. I quite purposely used some of the same values. And then you go to the next value, 33. And again we need to search for the smallest. We get the 14, and then the 14 and the 33 must swap. There we go. Then the 27 is used, and again I'm going to search through the array to find the smallest. We find 19, and then 19 and 27 must swap, and voila, now I've got 10, 14, 19, and this data is sorted for me. You can go have a look at the rest of the steps, slowly, carefully, or you can use one of the sorting algorithms if you want to. This one with the flashlight looks okay, so use any one of those that you want to. Okay, if I go have a look at the algorithm, because I'm the algorithm lecturer, Then I've got first of all a loop, and I've colored it in a little bit, my outer loop, to loop through the entire array from the start, this time not to the last element, to the second last element, so second last index. In the loop I'm going to assume that index is the smallest. I'm going to loop through the remainder of the array. I'm going to test if I get the smallest value, but we're only going to save the indexes. Okay? Not going to save the value, only the index, same as what we did with the object array. After the inside loop, inner loop, I'm just going to first check, are the two indexes at the same spot? Remember, if I don't need to swap, I'm not going to swap. If it is at different positions, then I need to swap my elements. So this is first of all the algorithm that you guys need to go and sit down and learn. So this is butt work. What is butt work? It's work where you need to go sit on your butt and learn the steps. You need to physically go learn the steps. But after you've learned them, like a little parrot, it would be easy to apply them to any type of programming situation. So if we go have a look at a program that we've coded in Unit 2, Lesson 2, where we saved a lot of prices, we can now go and add a button to sort the data in ascending sequence. So I've got the program running where I've got quite a bit of data saved, and obviously if I click on the button now to sort ascending, it's not doing its job yet. I still need to go and code these steps. I want all the prices to go from lowest to highest. So let's go have a look at the code. If I go to the button event procedure, I've already included the algorithm. This time around I'm going to go and code the statements for you. So I've got 3 indexes that I'm saving. My sort index that I'm going to use for the outer loop. The inner loop is going to use next index, and my minimum value, I'm going to save the minimum index. And here's my temporary data. I'm storing prices, so temp is also a decimal. First thing that I need to do is to loop through the data. I'm going to say sort index, start at 0 and go to array count. And what do I need to go to? Second last index. So array count minus 1 would always be the last. So if I want to go second last index, it's got to be minus 2. So that's one thing to remember. Next, sort index. There we go. Okay. Now I'm going to assume my minimum index would be at the smallest value. So min index would be my current array element, sort index. Now I've got another for loop, and here I'm going to use next index as the variable. Start at, and I need to start at this plus 1. So start at sort index plus 1 and go to the end of the array. Array count minus 1. And again, I'm going to add next index for the for loop. Okay, that takes care of that line. Now I need to test if my current element is smaller than the minimum. So if array amounts, current element would be next index, is smaller than array amounts stored at minimum index. My if statement, test if the current element is smaller than the minimum. then I'm only going to save the index. So now my minimum index is the index that I'm currently at in this for loop. After the inside loop, I need to test. So after that, next statement, I need an if. If my index that I've got for the outer loop, if sort index is not the same as minimum index, then I know I need to swap. So I know swap would be temp is equal to array amounts. Take the sort index, take array amounts, sort index, and now I want to save. Oops, what in this world did I code there? Take array amounts, the minimum index, and put it there in the sort index. And now array amounts of my minimum index. Where do I get that data from? From temp. Okay, so using the algorithm as a basis, doesn't matter if you now write VB code or Java code or C++ code, the steps would be exactly the same. And over here, I can just save and I can run my program. And here I've got my program, I've added my data. Moment that I click on sort ascending, oh, it seems as if nothing is happening. Why? Can you think? I only sorted the data. Did I display anything in the list box again? No. So then it's not going to work at all. I've got a show all procedure that displays all the data for me. So after the sorting, I just need to, right at the end, call the show all procedure, because I need to go and display the data. So if I run the program again, I've run the data of the program, I've entered exactly the same data, and if I now click on sort, voila, magic happens, because now the data was sorted in memory and then it's displayed for me. So you guys can go and you can have a look at the sort descending method to sort all the data in the opposite sequence. Okay, if I take now the student application, I've added students already. Over here I can see their data, I can view the semester marks, I can do quite a few things. But let's say I wanted to sort all the students per surname, or per semester mark, or per anything else that I want to. We're going to see how to do those steps. I've already included the algorithm over here, so now we need to add the rest of the data. Okay, can you guys remember what other variables I need? So I need my sort index, I need the minimum index, and I need the next index. Stick to exactly the same names always. Then I need not a temp or just a normal variable, but an object temp as from the type student. And again, I'm now going to use exactly the same statements as before. So I've got a for loop. My sort index must go from 0 to array count minus 2, second last element. In the loop, Minimum is the current value, so that means minimum index is equal to sort index. Then I've got a for loop for the next index, and it's got to go from sort index plus 1 until the end. Oops, minus 1, hey? Okay. I want to sort the data in surname sequence. So let's go for if array students, current element would be next index dot surname. Oi, what in this world did I press now? There we go. Dot surname. If that is less than array students of minimum index dot surname. So that is rather important. Let's just make that a little bit smaller. I want to sort in surname sequence. So I need to go dot surname and compare that to the other surname. If it is smaller, I want to save the new minimum. It must be from next. And then after the if statement, I want to compare. If my sort index is not the same as minimum index, then I want to swap my data. Now object temp will be at array students sort index, then array students of sort index. I'm going to get that from array students at minimum index, and then in the end array students minimum index. Where do I get that data? I'm getting it from object temp. And voila. So these really minor differences. If I wanted to sort per ascending, let's say semester mark, what do? I simply call the calculate semester mark method, and I compare that data to the calculate semester mark method. Okay, so depending on what data I want to sort, I will compare the stuff. For my program, I wanted to compare surnames, so I need to compare the two surnames. If I now run the program, what do I need to remember? I want to display the data after the loop. So if we can have a look, currently we've got a show student that's coded. I just need a loop, so I'm gonna be a little bit lazy. I've coded it already. We never go and copy code, so this is a method only me will use. Private sub show all, let's say. I'm going to move all that code there. Now I'm going to go show all. Whenever the form is loaded or when the button view data is clicked. And now also going to call show all as soon as I've sorted my data. So let's run the program, have a look. I've added the same data already just to save us a little bit of time. So if I go to view, we've got Motlong, Cubana, Andrews. If I click on, I must have changed the name here by accident. the text. If I click on sort, it sorts Andrews Bana Matlong Nku in surname sequence. That other code executes. Let's just go make sure that I go and type in sort how ascending surname sequence. There we go. The button is named button sort surname. Okay, so this is a little bit complicated. This ascending sort. Descending sort, then you're only going to now not look for a minimum but a maximum. And we're going to check for the biggest of the two values. It's a really useful algorithm. You need to know it off by heart, but then you can easily adapt it to any situation that you might find. Okay, thank you. Have a good day.